Hi, so this video is going to be about factoring the sum or difference of cubes. So a perfect cube, we'll start there so you can notice whether we have it, is something to the third power. So remember our perfect squares were 1, 4, 9, 16, and so forth. We wrote that down when we were in the quadratics unit. Now we're in polynomials, so we're looking at the exponents higher than 2. So the first one would be 3. And so there's patterns with the difference of cubes or adding cubes. I can change this to a plus, and it's the same thing. How you recognize whether you have a cube is you'll either have x to the third power or you look for the numbers that are perfect cubes. 1 times 1 times 1 is 1, so the first perfect cube is 1. 2 times 2 times 2 would be 8. So that's your next perfect cube. 3 times 3 times 3 is 27. So that's your next one. 4 times 4 times 4 is going to be 64. 5 times 5 times 5 is going to be 125. And that is our first 5 perfect cubes. If you want to go and find more, you can. We probably won't see any that's going to be bigger than those. Okay, so now let's take a look at the pattern that we use to realize. So if you have 2 perfect cubes where you have an adding or subtracting of a perfect cubed here and only 2 terms, and they're both perfect cubes, and you're going to want to think of this pattern. So this worksheet walks you through nice. So it says first term, second term. So take the cubed root. So this will just be a minus b. Now first term squared. So this is a squared. First times the second. So this is in the middle. Second term squared, so then you have b squared. Now the first sign's the same, which is why that's subtraction. The second sign here is going to be the opposite, and the last one is always going to be positive. Okay, so let's look at that for the same thing goes with the sum. So first term, a, second term, b, first term squared, multiply them, second one squared. Always positive. This sign will match this sign. This sign here is going to match this sign. This sign is going to be the opposite. So if this was plus, this needs to be minus. And that is your pattern. So on the next slide, we're going to take a look at all the different examples and putting this rule. So write this rule down in your notebooks so that way you can revisit it later. Okay, so here on this page, again, if you want to write them down, this is the rules we just wrote. Here is more steps for you. This we just wrote on the other page. Here is extra steps to help you solve this if you would like to do that. Okay, so here you would look at this and you would say, I have 2 perfect cubes. X to the third is a perfect cube within itself, and 8 can be rewritten as 2 to the third. So these are perfect cubes. So if I take the first term without the 3, second term without the 3, first one squared, multiply them by each other, second one squared, and the second one is always positive. Now go back and do your signs. The sign of the first term should be the same. Sign the next one should be opposite. And now I have factored my difference of cubes. Now the sum and difference of cubes, if you look at the end, this one will not be factorable. You can't find any factors of 4, positive 4, that's going to add to a negative 2. It's not possible, so you don't even have to try it. That's a pattern that's not going to end up happening. That's as far as you're going to be able to go. Okay, so I'm going to look at D, pause the video, and try B. if you want. We'll have more examples for you to try after. The next one, you can pause the video again if you want to try D, and I'm about to show you D done out. So why don't you pause the video, try D, and then I will walk you through D. Okay, so hopefully you tried it. So we would look here, what is the cubed root of 125? Is 125 a perfect cube? Well, you would ask yourself, does 2 times 2 times 2? No, not 3, not 4, but it is 5. So I can write this as 5 times x to the third. And again, we have that 8. 8 is 2 to the third. So I can write it like that. So take the first term, second term, first term squared. So 5 squared is 25, x squared. Multiply the 2 times each other. And then square the last term. And this is always plus. This sign should match. This sign is opposite. And you have a nice little pattern. Okay? So I'm going to want you to pause the video and try C and B. I'm going to quickly give you the answer afterwards. Okay, so for this one, cubed root would be x. Cubed root is 3, same sign. First one is x squared. Multiply each other and square the last one, always positive. So minus in here, okay? This one here, cubed root is x. That is the fourth to the third, so that's going to be minus 4. Signs always match. Square it, opposite sign, multiply it, square the last term. Hopefully you did that. Okay, the last one is a little bit tricky because you have to remember you should always be looking for your GCF first. Here, what would your GCF be? You could try them out. In this case, I'm going to take out a 2. If I take out a 2, I'm going to end up with 8 x to the third plus 125. Now I can realize that this is 2 to the third power, and this is 5 to the third power. So first term would just be 2x. Second term would be 5. Keep the sign. First term squared, 2 squared is 4, x squared. Multiply the 2. And then that should be the opposite sign in between. Plus, square the last one. And bring that GCF out in front. Okay, try the next two in your Nearpod. If you have questions, please let me know.